Just a second. Uh, I would like to have a little bit of audience interaction before starting because, to be honest, I'm feeling a little bit nervous. I'm not sure if whatever I am saying is going to real people. So can I get a little bit of hi and hellos from the audience? Fabian, Marianne, are you there? Hi.
Yeah.
Vishal Manoj.
Hi, hi, Lipsa.
Hey,
Good
hi,
morning.
Fabian. Where
Hi, Lipsa.
hi, Vishal. Akshay, Rashika, Sumit, Gatule, and Swapnil. Are you there? Hi. Are you there with us?
Hi, Lipsa.
Hi,
Hey,
hello.
hey, 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 hey.
Guys,
Hi.
hello
Thanks.
everyone.
Thank you, people for joining. And yeah, guys, since this is Web3, you must, I'm wondering, how much are you aware of this technology? Are you newbies? Have you tinkered with this stuff a little bit? And you are expecting that we give you some high level stuff, or are you completely unaware of what Web3 is and you're just trying to just use this platform to know what Web3 is? So somebody can volunteer and tell us like what are the expectation and something like that. So maybe Fabian, can you go ahead and tell us what are your expectations from
Uh,
this session?
yeah, I mean, I've been researching about this field for quite a month, but I'm a
Mhm.
bit confused whether metaverse is Web3 or everything, or the internet that is connected to blockchain is Web3. I'm not sure about that. I'm
Mhm.
just still new into this. So I just want to know, like what is actually Web3? What are the
Mhm.
opportunities like developers like us can do?
Mhm.
So on and
Mhm. Mhm.
so
Mhm.
forth. So
Awesome, awesome. Mhm.
to
Mhm.
rate
Continue.
to rate my knowledge, I would be again a beginner on this.
Awesome. Just to let you know, I am a complete beginner. So I also joined in seeing that this is a cool term, and let's find out. I'm a complete beginner, so I'm taking the beginner,
Okay.
parts where I'll talk about why we needed Web3. Anyone else? I will just any other person who would like to share where he is in the Web3 journey, exploring about Web3. Sumit Ghatule, would you like to go ahead? Hi, Sumit. Or maybe Rasika, would you like to share your expectations about the session?
Hi, Lipsa. Actually, I'm not aware about this Web3, so I'm
Mhm.
not sure.
Okay, awesome. You have joined this session and you will learn it. I sure that whatever I have learned, whatever my teammates have learned, we will be able to give some knowledge to you. And thanks for joining again. So, okay, I pretty much get some idea of what you guys are expecting from the Web3. And yes, this is a new topic and we all are new to it. So let's get started. Yeah. So this is the order in which we will be presenting. So first, I'll be presenting about some of the basic topics, and then OP would be presenting about the architecture of Web3, like the whole full stack architecture of Web3, and Rahul would help you get started with the tools and all the prerequisites you need to become a Web3 developer. Yeah. And I must say he is a quite a Web3 developer, so he will help you out. So without further ado, let's get started. Why is it moving forward? Yeah. So again, we talked about all the buzz about Web3. So everybody seems to be talking about, not everybody, maybe a bunch of us in the developer community are talking about Bitcoin, blockchain, NFTs, IPFS, and dApps, and what are all these? And we must be wondering in this world of Web2, where we are enjoying, our Instagram reels, YouTubes, and involving in the Twitter fights. Why would we need this new technology called Web3? So this is our, the session is our a little bit of initiative to bust all these, things for us and get a little bit of insight of how the Web3 architecture works, what are its building blocks. So again, let's get started. What are we going to cover? I pretty much told it. So evolution of the web, how we came to this point where we need Web3, the Web3 architecture by OP, and all the prerequisites that we need to become a Web3 developer. Sorry for that. Just a second. My bad. Okay. So a brief history of web. So before learning about Web3, I thought let's understand why we started in this journey of internet and web, why it was all required. So let me present to you what I found out. Before that, I'll give you a little bit of heads up that the web, the term web, is not same as the internet. Yeah, the web has become so popular that it has come to become synonymous with internet, but which is not. Web is just a document management system or an information gathering system built on top of an internet, where internet is a network of networks. It is simply interconnection of the networks, which on the top of which the web is built. Now we'll learn about how we have evolved in this web technology. All right. So first we came up with internet, then web 1, web 3.0, which is also called semantic web, but this is not we are going to talk about. We are going to talk about some other thing else. So then web 2, then web 3. All right. So first we'll talk about internet, why we needed internet in the first place. All right. So here we go. So there is an interesting story behind the finding of internet, and that is during the Cold War time. Sorry guys, just a little bit. Give me 2 minutes. I'll come back. Somebody's at my door. My bad.
So there are people asking where the feedback form will be at the end of the session. And for some context, at the end of session, if you choose to fill your email address, I will mail you a minting link. I will also show you how you'll be able to mint your first NFT. And as long as you don't lose access to your wallet, it'll stay in your wallet indefinitely. We have Lipsa back. So
oh, sorry. Delivery guys, I'm so sorry. Okay. Anyway, where was I? My flow is broken. I'm so sorry. Okay. I was talking
why we needed the internet.
Okay, thank you so much, Mishal. Thank you so much. So why we needed internet? So I was telling a interesting story, right? So it was a time of Cold War between US, between the world. So at that time in 1950s, Russia, Soviet, was the first nation to send Sputnik. It was the first man-made satellite to be sent in the space. So what US people, they were very scared of what attacks will that technologically advanced nation Soviet will do to them. They were fearing nuclear attacks due to the Cold War. And with all this fear, they started to invest a lot in their science and technology. So they started heavily funding various research institutions. So one of those research institutions was ARPA. ARPA is basically Advanced Research Project Academy, which basically dealt with the connection of with the computers and building a network around it. All right. So question is why we need to connect computers? So the computers were not this small, well-designed, portable, sleek structures that we are using in our homes. Rather, at that time, they were very big. They were called mainframes, and they were big and they were ineffective. They ran just one task at a time. So to run multiple tasks, for example, experiment required multiple tasks, we had to deploy multiple computers to run that task. So that was for that purpose, we needed to connect multiple computers to put together their computing resource. So that is the reason why we needed networking, right? And for networking, we also needed the computer to do some communication between them using some common protocols, right? If we don't have a common protocol, we can't communicate, right? So that is the requirement of internet, why we needed to connect to the computers. Just a second. So as I said, the solution to that is connecting computers and making them talk in a similar language, right? To make to aggregate the computing resources. But before internet, we had something called wide area network called WAN. But it had its limitations. What were its limitations is that the WAN was built on top of telephonic networks, and it could be only situated in one close-knit place. And apart from that, the computers connected via WAN did not speak any common coherent language. They spoke in their own language. So it was literally impossible to convey one particular message and understand it. Problem number two. Problem number three is they deployed a method of networking called circuit switching. Familiar from computer science classes, yeah? So circuit switching is basically what is that you will establish connection over one particular node via only one link, all right? Only that link would be specifically used for communication, and then we'll send a whole data packet over that link continuously until the message is reached to the final node. But sometimes what happens is that the node sometimes, the connection sometimes gets disrupted, and we'll have to send the whole message over again. That was very tedious, and that took a lot of time. Inefficient in sending the message. That was the third limitation of the one. Then the fourth limitation at the time of the Cold War was that they were centralized. So if there was a nuclear attack over the telephonic lines, over which the communication was done between military and this research agencies, then the one network is that communication is disturbed destroyed by the nuclear attack, then the whole network is gone, the whole communication is gone. So that was the problem with one. To solve all this problem, ARPA, that I was talking about, Advanced Research Project Academy, they came up with the idea of something called a packet switched network. So this idea was actually revolutionary, and this was the building block of internet. Again, from computer science classes, you must have heard somewhere. So again, I'm reiterating, being a computer science lecturer now. So a packet switch network is something like, so there are two networks, there are two nodes which are trying to communicate, and all those nodes in between are interconnected, all right? First node, when it is sending data, it will break up the data into small chunks, small packets, and send the data in all directions. In all directions it will send, and it will send data as fast as it can. So the data will go in this circuit switching network, it must have gone in this way, in this way, all right? But in packet switch network, it will go in all direction, all possible direction, all the nodes, so that all the node will have some chunks of data, all right? And finally, in this destination node, all this data would be collected and merged, and this data will be received by the receiver. All right, this is the idea of the packet switch network. So how is it better than the previous model of circuit switch network? So first thing is, the single point of destruction, single point of failure is not there. So since this is a telephonic line, there are no telephonic lines, these are wireless. So if something nuclear attack is here, the communication will all break down, but in this case nothing will break down. If this node is if there is attack on this node, other node will serve as a relay for the data, all right? So that is the aversion for that is how we dealt with the single point of failure. And second thing is it sends data as fast as it can, so it is very efficient in that way. And this was operating in one place because it was telephonic lines, but here we can access data from anywhere in the world. Like the soldier who are there in the deep jungles could access the data sent by the scientists from, UCLA, from any university. That was quite amazing and cool. So yeah, so that was one solution to the problem that was posed. The second problem was communication, right? We had to come up with some common protocol through which we could talk. So that protocol was TCP/IP. Computer science classes, just remember. So TCP/IP is nothing but a protocol through which everyone agrees to, okay, we'll talk in this language, and the computers, the networks communicate by that method. So that was a solution to all the problems, and this was the genesis of internet, you guys. So internet is here. So this is literally, I copy and pasted, this is ARPA's first map for their network. So without ARPA, we wouldn't be having internet. Without US fearing Sputnik, the Soviets, we won't have this internet that we are enjoying today. That is pretty amazing and cool. So we have this internet. We have internet, which came up in 1970s. Then we had Web 1, the first version of web in 1991. Between this time, many things happened. Like we had our first OS, Unix, we had email, we had DNS system, a lot of inventions. The internet morphed a lot. Then Tim Berners-Lee, he came up with this idea of web. Just give me 2 minutes. I'll sip some water. Again, this has a story. Why we needed web? Let me tell you. So we have come from a research background. I mean, in our 4th year, maybe I'm assuming everyone here is some kind of, have been an engineer in the 4th year. They have worked in some research projects and stuff. So in research project, you remember that we gave references or citations to other papers, right? So back in the time, when they used to write research paper or when they read books, they also gave citations. But to find the other book that is cited via that citations, they needed to toil a lot. They had to go through libraries. They had to, email the authors to get those resources. That was a pretty tedious task. So Tim Berners-Lee the founder of the web, was very frustrated with all this tedious tasks. So he wanted to find a certain mechanism built on top of internet, a document management system on top of internet, which would fetch the document that we want from anywhere in the world. So that was his idea. So he came up with this interesting magic idea of hyperlink that we take for granted right now. But in that time, it was revolutionary. So the idea is that when we click this hyperlink or this citation, the internet will take, the web will take this responsibility to bring down all the document that is there in the world of the internet and bring back that document to us. So on the basis of this idea, the Web 1.0 was created. So Tim Berners-Lee, he built the language HTML, that hypertext markup language to build the web pages, to create hyperlinks. He created this protocol called HTTP through which we do the web surfing, and also he built the web server and the first web browsers. And literally, this is the first website that he created to demonstrate how all this works. So yeah, he heralded the era of the Web 1.0. So here I'll talk about a little bit of component of what the Web 1.0 consisted of. So this was a phase when everything was very static. We could not, interact with the server. Everything, we just passively went through the static pages that was served in the servers, and we could not give in our data to the internet. To solve this problem, another phase of internet was coming up, and that was Web 2.0. It was first coined by O'Reilly. He was some media person who came up, who popularized this idea of Web 2.0, of web as a platform. where the user could interact with the web. Earlier, it was just one way. The user passively went through the static pages. But now in the phase of Web 2.0, the user could actually, interact with the web and set the information dynamically with the web. So yeah, so Web 2.0, the onset of centralization, the centralization part we are going to talk about in a little bit. So bear with me. So first of all, as I said, it's a read and write web where we had, irrespective of the static pages, we could given information, update some information and stuff. And this heralded a era of social media, right? In 2004, as I said, it all started, and in 2004, Facebook opened its pages to college students. So yeah, it was synonymous with the era of social media. And in this phase, some companies were gaining a lot of power. You know who? These are companies like Amazon, Facebook, and the likes Google, Twitter, etc. These companies were amassing a lot of data and data and of the users, and also amassing a lot of capital generated from the user data. But how? So they leveraged this ad-based revenue, that irritating ads that are popping up everywhere right now. So this is all part of this ad-based revenue. So what these big companies do is that they give us their free softwares that we use, and in the hindsight, they steal our data and they provide those data to the ad agencies. And I tell you what, this is a $1 million, $1 trillion business that they are doing, for stealing our data. Sometimes they ask for permission, and sometimes they just take it. So that is all part of the centralization, the data and everything, power, the data centers, everything that is centralized in this big tech. So you must be thinking, okay, they are centralizing our data, but why do we care? It's fine. We are getting the services that we want, all right? But just let's think a bit on it. So what kind of data? Let's understand that what kind of data that we are providing to them. So the first is generic, like our date of birth, location, blah blah blah, yada yada yada, and also some of our facial features, voices, like when we use Instagram filter or Snapchats. Yeah, we give away all of that to the AI machines. And the most importantly, our intellectual properties. Like Web 2.0 is the era where the blogs, the content creators, all of those are online, and those are our intellectual properties. Those data are also under their control, the control of the big tech. So as I said, it's a $1 trillion business, and they are making money out of our data. So the question is, why don't we own it and take the ownership in our hand and take all that royalty money to ourselves? Thought about it? So let's talk about the drawbacks of Web 2.0 bit by bit. So the dangers of middlemen and the trust issues. All right. So whenever you must be logging into some unknown website, they ask for login. So we do some single sign on using Facebook or Google. Why do we? They are just middlemen through which we trust, and we use them to trust some third party. All right. So we have created this trust system on this middlemen, and these middlemen are innumerous. For example, we trust banks for payments, DNS system for trusting websites and users, Google for information, Facebook for community, YouTube, Spotify, who are intermediary between the content creators and the content consumers, Amazon for consumers and vendors. There is this system of intermediary or middlemen between the user and actual content and the value creators. This is a little bit problematic. We'll see how. Okay, so the first problem with this idea of middlemen and centralization is that they are selling our data. They're selling our data and making a lot of money out of it, as we mentioned, and those money could be ours. The second point is data breaches. We must be thinking that, okay, those big companies like Google, they have big data centers, they have big infrastructures, and they must be implementing high rise that security schemes. So their data is, our data is safe in their hands. But no, it's, the data is not at all safe. I mean, you must have learned about that Facebook was hacked in 2021, and literally billions of our data was given away to the cyber criminals. So data breaches are happening, and that is because of this centralization of the data at the hand of one people, of certain amount of handful of people. So the third problem is concentrated control. So now literally in any small company that starts out, that it does not have the hassle of buying their servers and but rather they are taking rent from the servers that are owned by the big companies again. So that gave rise to another term called cloud computing, which is distribution of the cloud computing resources over the network. So that is a problem. Why that is a problem is because, for example, let's say n number of companies are using the server of Amazon EC2 instances. Let's say the Amazon data center went down, then all the companies, n number of companies that are using the servers from Amazon EC2, they all will be affected. So again, the problem of single point of failure is again creeping in, that we solved initially by decentralization. So that is one problem. Second problem is, in this era of economic disparity, the web is again becoming that kind of coming into this kind of disparity situation, where we are giving so much power, so much control, so much trust to these third parties. A little bit problematic, right? Then the next problem is censorship. So since all this data, all this Instagram, Facebook users who are striving for the free speech thing, for any social change or something, the government is attacking, holding the collar of this big tech companies, saying that see, you control all this data, so you put censorship on this people. So that is easy to, the censorship thing is very easy to implement when all the data, all the communication is done via this middleman. They just can take hold of this middleman and make them accountable of what content we are trying to create. So this is you can see this is a threat to our freedom of speech. Somebody drew something. Okay, is somebody bored? Should I tell a joke or something? Anyway, okay, moving on. Okay, the next problem is concentrated value. So as I said, TikTok and Instagram, they are middlemen between the content creator and the content consumer. These companies are making lots of money out of the content that is created by the content creators. Rather, this royalty share should be shared with the content creators in right amount, which is not being happening. So these are all the problems that come with centralization with Web 2.0. Now, the solution to that is Web 3. But before that, Team Berners-Lee again suggested another idea called Semantic Web, which is also known as Web 3. We'll get confused between Web 3.0 or Semantic Web with Web 3, but that is not we are talking. Somebody is drawing.
Yeah, let
Somebody.
me enable annotations for people. I think Lipsa. Let me do that one second.
Okay, that's fine. That tells that people are bored. Okay, no worries. I'll fast forward. Don't worry. Just bear with me a little bit. The interesting part are coming with OP and Rahul. So okay. So let me give a quick detour on Semantic Web before we go to Web 3. All right. Because just to give you insight that these are not the same thing. You should not get confused. So Semantic Web, what is it? Is that, currently the data are in silos. what do I mean that data is in silos? So you have an account in Facebook, you have an account in LinkedIn. So in both these accounts, you update your informations like name, place, location, your job description, etc., etc. So those are two different documents, right? So if you update your job description in LinkedIn, there is no way that Facebook will know that your job has been updated in LinkedIn. So you'll have to come to Facebook and update that job description in Facebook itself, right? So that is what I mean by data in silos. But Tim Berners-Lee, who is constantly, working towards connecting everything, he thought, okay, what if we connect data rather than we connect the files? So semantic web is all about connecting data pieces, so that if something is updated in some place, we can link that data to other place and it will be available. For example, what will happen if we update some job description in LinkedIn, it will automatically reflect in Facebook. So that is the idea of semantic web, but we are not going to talk about semantic web at all. That was a detour. Let's say hi to Web3 finally, which you must be waiting ki ye ladki kya bol rahi hai. But now let's talk about Web3 a little bit. So I have said that Web3 is a path to decentralization, right? We learned about all the problems.
Lipsa,
Yeah.
sorry to interrupt, but just a question. This semantic web that you talked about, is it still in theory or is it just implemented?
Well, as I said that I am again a newbie, and I read somewhere that it has been implemented a little bit, but to be honest, I'm not very sure. I'm not very sure. Sorry.
No problem. Just a question.
But
Newbie as well.
that makes me happy that you are listening to me. I thought nobody's listening and I'm doing some yada yada yada, and everybody is waiting for Rahul and Upi for their architecture and stuff. But thanks, Meenal. Okay, so okay, let me come back to decentralization. Yeah, so Web3. So Web3 states that it's a democratic web. It's of the user, for the user, by the user. But how? We'll find out. It also said that it has increased data security, it is more scalable, and it provides user with more privacy. But how? We'll find out. And it is built upon a system called blockchain. The blockchain, a term you must be hearing a lot these days. But let's find out what blockchain is, the basics of blockchain, all right? So I went through some YouTube videos and stuff, and this is what I found out. So blockchain is a decentralized, distributed, immutable ledger. A lot of keywords. Let's break it down. So decentralized, what does decentralized mean? Is that the blockchain data operates in a peer-to-peer network. By peer-to-peer, what we mean is that each node serves as a server, also as a client. I mean, there is no middleman, there is no middle server which acts as an intermediary between the client and the actual server. Rather, every node in the system acts as a client and the server. All right, that is peer-to-peer. So that is why it is decentralized, no centralization. All right. Second key word that is used in this, this thing is distributed. So what distributed means is that the data, earlier I said, the database, the data centers, the database is there in the data centers of the big tech companies, the intermediaries, the middlemen. But here the data is distributed across all the nodes of the peer-to-peer distributed network. Distributed. Next key point is immutable. Immutable, that means the data that is there in the blockchain is very, very difficult to mutate, to change. It's very difficult to change the data. So that is the basis of, security of the blockchain. And let me tell you, it was adopted, this idea of blockchain was, adopted by Satoshi Nakamoto, who is an unnamed being. He refuses to name himself. He's he's a he or she, or he's a group, nobody knows, but he created a Bitcoin using blockchain technology. all right? But we will find out how blockchain works. As the name of the blockchain suggests, it's a chain of blocks, right? Intuitively, it's a chain of blocks. But what is a block in a blockchain? So each block in a blockchain contains data, all right? The data can be different as per the specific application. For example, in Bitcoin, the blockchain, one block of a blockchain can contain, the transaction ledgers. For example, the sender receiver information or the amount. That can be the data in a Bitcoin blockchain. The next thing that it stores is a hash. So what is a hash? Hash, you must have learned in the cryptography lessons, that the hash is basically the output of a function, a cryptographic function, SHA or whatever function that there is. So it's the output of the function that generates a random string as output. Okay. And the property of hash is that whenever the input changes, whenever we tamper a little bit with the data, the hash also changes. All right. And the third element that is there in a blockchain is the hash to the previous block. You can imagine a linked list, right? Linked list data structure where each link, each data or node is linked with the previous link. So in that manner, each block stores the hash of the previous block. And this hash is again taken into consideration while making this hash. All right. So this is what the one block of a blockchain looks like. And this is what a blockchain looks like. So as I said, it contains data, hash of this current block, and hash of the previous block, hence forming a linked list like system, which is encrypted by some hashing technology, encapsulated in some encryption. The first block is called Genesis block. It does not contain the link to any previous block. Obviously, it does not have any previous block. So how this simple idea of linked list with encryption is helping us achieving that security and privacy that we are talking about. So imagine that if somebody wants to tamper with the data of this block, if somebody tampers, as the property of hash, this hash will change, right? This hash will change, and this is linked with the previous hash. Now, what will happen is that this block will say that this block is invalid. And similarly, all other blocks will say that we are all invalid. So that invalidates the whole chain that comes after this, right? But this is, we can generate hashes. We can, tamper the data, generate the hashes, and build the hashes for all the subsequent blocks. That is easy for any computer with high computing techniques. But how do we overcome that? Right? There are powerful computers. We can achieve this easily. So to overcome that, there were two solutions. First thing we can do is the computers can quickly calculate hash. That is a problem, right? But somehow, if we could slow down the process of creating hash, then it would be difficult to create, new hashes and add to the blocks. So that is the concept of proof of work. So proof of work is nothing but adding a little bit of difficulty to the process of creating hash. So what they generally do is they specify that in our blockchain, all the hashes will start with certain specific amount of zeros. All right. So if you could come up with that kind of hash, then that will be accepted in our blockchain. But that thing, finding a hash that starts with a certain amount of zero is very difficult, actually, cryptographically, if you see. Literally, it has to be mined out from, the number which is of the order of 2 to power 200 or something. So that is really very difficult. And for Bitcoin's case, it takes 10 minutes to add a new block. So that makes the job of hackers difficult, literally really difficult. And also on top of that, we have this peer-to-peer network. So let me explain that a little bit, how blockchain operates in this peer-to-peer network. So for example, there is a peer-to-peer network and you as a user join in this peer-to-peer network. Then you will get a copy of all the blockchain data that is there in the network, and you will verify that, okay, my data is, that is fine, everything is correct, all right? Whenever a new block is created, whenever somebody generates a new data, a new block, that block is propagated to all the nodes in the peer-to-peer network, all right? So all the nodes, they will verify that, is this block valid with my current block? So how would they validate that? So they will just find out the hash of the current block and check if the new block's previous hash is pointing to our block. Then they will verify that yes, this is valid. But if some data is tampered, then the hash will invalidate, so they will discard the block. So if some hacker would try to take control of, tamper data and try to take control of the network and propagate its data, he has to generate the hash of all the blocks doing this proof of work, and then he has to take control of the whole peer-to-peer network. I mean, more than 50% of the peer-to-peer network, in order to tamper a data. And that is, literally really difficult. And that is the basis of security of blockchain. That is why they're making tall claims that our system is secure. And yes, it is secured by the cryptographic methods. Okay. Moving on. Okay. So we saw the basic of blockchain and how it implements its security and how it is decentralized. But how will this decentralization and security solve all the problems that we have seen in the Web 2.0 centralization era? All right. So let's demystify each of this a little bit. Okay. So first of all, we talked about single point of failure, right? Like the data, I mean, the big companies have all the data centers, all the servers. If they shut down, all the companies shut down. That is not going to happen in Web3, because as we discussed, we are like Web3 is all about peer-to-peer network. If one node fails, other node can act as a server to other client that is asking for data. So that is the antidote for single point of failure. Second is middlemen. Bye, we don't need you, because this I have not talked about. Talked in that much clarity, because we have not covered those those cryptographic keys, public keys, private keys. But just to let you know that this is done through some cryptographic keys, which allows individual to prove their identity without handling sensitive information. So what we do is that we create accounts in various, LinkedIn or Google, and we assure that, okay, your data is safe with you and you can use this data to log into other system. But in Web3, in decentralization, we don't need it. We just need a key to verify our data without giving much of our information to ad agencies. So yeah, so that is how we are building the trust. The second thing is the same thing, that we just need one key and not multiple accounts to say that, yeah, I'm Lipsa, identify me via email or GitHub or blah, blah, blah. We just need one key. Okay, all handled in Web3. Then this is interesting. This is called IPFS versus HTTP. So let me read it out for you. So what happened in HTTP is that we used to access data via location. But in interplanetary file system, this is a new version of HTTP, you can say. So any device can store and serve the web's content, as it is decentralized. Every piece of content on IPFS is given its own unique code and hash, rather than using universal resource locator. That is basically the location of where the document is. Rather, we will be using hashes. We'll be using hashes to locate something, to locate information, and the network that then serves up the content from the nearest node, regardless of where it originally came from. By leveraging the distributed network of hosts and servers, the IPFS is able to remove the single point of failure and the potential censorship that come along with the web servers. You can read more about it. I'm just throwing you some keywords here. Just go and read about it a little bit more. Then we talked about the problem of the content creators. So here we can build something called decentralized app, which Rahul is going to talk about how to build them. I mean, prerequisites of it at least. So this app, something called Audius has been created. Is a decentralized music streaming platform that puts content creator directly in touch with the audience and remove the need for the middleman almost entirely. While Audius team created the platform, there is no longer a need for the sole operator and beneficiary. Audius lives in the blockchain and is owned and governed by its user through its platform's native cryptocurrency called Audio. The ability of the pay creators directly to work with and give them a say in the platform. They use a massive shift in the creative world. This is especially true in the music industry, where the majority of the revenue and decision making power still goes to the middleman. So the revenue directly comes to the content creator rather than going from the middleman. So that is the idea. Again, just to give you a this key terms, just go and read about it a little bit. Finally coming to end of my part. I was doing some yada yada yada. So Web3 has its supporters, it has its fair amount of haters as well. Many people the critics who are opposing Web3 have this points to say about Web3 is that of the scalability. So whenever you're doing transaction on Web3, if you have understood the that thing of proof of work. So proof of work takes a lot of time to build. I mean, to add a block, we have to spend a lot of time in it to mine that data. So that is a little bit, that makes the transaction a little bit slower, and hence they are doubting its scalability. The UX interacting with Web3 application can require extra steps, software education that Rahul is going to talk about. Then accessibility, the lack of integration in model web browsers makes Web3 less accessible to most of the users. Since it's new, obviously, I mean, it's not all the browser compatible, so a little bit difficult. Cost, most successful apps put very small portion of the code in the blockchain as it's very expensive. You can see, I mean, lot of the network and the cost of mining the data. And the last is energy consumption. So that is a major concern of Bill Gates as well. So he says that a lot of energy is being expended in creating doing the proof of work. So that requires a lot of computing resources. So that is not quite environment friendly. So these are what critics have to say about Web3, but it's up to you, like if you accept it or you can discard it. But this is a new idea, just let's go ahead with it. I had to present this much about Web3. OP, you can take it from here about the architecture and stuff. Yeah.
Thank you, Lipsa. It was wonderful presentation and efforts. So I like to introduce myself first, and before that, let me share my screen. If you guys can able to see, can somebody voluntarily say, is my screen visible?
Yes, it is visible.
Yeah, okay, thank you. So myself, Pachoriya, working with Talentica since last 9 years. Yesterday it was 9. So yeah, so I think Lipsa has given you a quite good context about the Web 3.0, and I think my camera is not enabled. So if you want me to do that, give me a moment. So yeah, on the current slide. Okay, so yeah, I think I assume that we all are engineers and mostly from the software background, and currently we are working on the Web 2.0. So where architecture is quite simple. So user request via the browser and interacted by the help of some front end. This front end is written in the languages like JavaScript, HTML, CSS, and there's a lot of big list. And this front end, with the help of some APIs or some other interaction methods, they interact with the backend. So which may be in a high level languages like Java, Python, or Go, whatever, Node.js, but the list is again huge. and this backend also interact with the database. So this is very simple. It looks simple, and there's a lot of complexity here, but let's go with the abstraction part of it and make the things easy for you. So this is a simple web 2.0 architecture where most of us we know around this. So let me introduce my friend, Mr. Politician. So he's not Modi or he's not Yogi, but he is someone who try to understand web 3.0 in his opinion, and I will try to gamify the things or simplify the things in the layman technology so that we can understand the stuff here on, so that you can try to link the architecture in easy manner, and that will help you to remember the stuff as well. I will try. Okay. So just one sec. Let me do this. Yeah. So the architecture is little bit different here. So views are all again interacting with the help of browser, and some front end is there. There's a new thing which is there is provider. There's a new thing which is known as IPFS and so on. There's something known as smart contract, EVM, and blockchain. So let me give you a context. Suppose consider you want to go for a voting, or there's an election season coming, right? Just finished in few states, but there's an election season. So what we go with the signer part. This is a private key of this politician, nothing but an election symbol. If you violate this particular election symbol, that is kind of a private key, so that you are going to vote to this particular person or this politician. So this is the one part. Then there is another thing is known as a smart contract. So consider like this politician say, if I win, I will able to do this, I will able to do that. So he has some ideas. Those ideas is nothing but a smart contracts. So then we have this our front office, or what here we do is we keep all our fancy stuff. So the front end is almost same as in the web 2.0. Then we have provider. So we need someone who can communicate for us, this politician. So whatever the information they want to communicate to the other guys or the audience. So the media is kind of media. Provider is nothing but a media to this politician. Then this, okay, EVM. So ultimately who does the job? The EVMs or the Ethereum virtual machines do the job. So those are like kind of government departments. This politician promised something, but actually who implement those is the EVMs. On the same thing, like blockchains, those are the data points where we want to process the stuff and all. So it's sometime it may be a survey data, sometime it may be new data, but the thing is whatever data we have, it will never going to be we keep previous data. We cannot temper the previous one, as the Lipsa has already mentioned, like the basic property of blockchain. And then this IPFS. So IPFS is a kind of a personal secretary or personal assistant of this politician. So suppose I want to go for some permission to this politician. So what I used to do is I will trying to collect all the information. And okay, so let me add a few more things. So suppose this particular permission needs more than one iteration to get the permission. So what we do is it's not easily this politician is not easily accessible to all the guys always, but their personal assistants are. So we try to gather all the information with the help of this personal assistants. We communicate our messages, we put our information with them, and once we are ready, we try to connect with the help of IPFS to this politician. So I try to put some analogy. Let's so is everyone with me here, or do you want me to repeat particular stuff? Anyways, I'm going to developers opinion as well. Anyone? Okay, I think sound as no sound means everyone is able to grasp whatever I'm trying to tell. So yeah, so signer, as I mentioned, nothing but a logo of this particular. So it's a private key, basically a private key. Okay, sorry. Okay, private. So MetaMask is one of the tool which help us to handle key management stuff. So the providers, there's a two-way to do the things: either set up your own system, or we can use of the third-party system. So currently in the market, we have vendors like Alchemy or Infra, QuickNote. So this works as a provider. On the smart contract side, we have some languages as Solidity or Viper, which help us to write the logic or the manifesto of this politician. EVM is nothing but one who process this smart contracts. Whatever the business logics we have mentioned in our smart contracts, this will be executed with the help of EVMs. And yeah, IPFS is kind of distributed file system. So distributed file system, it means the information resides on more than one node, and there's two vendors there, so on. So they have some similarity and some difference, and some difference. So one of them is like in the IPFS we have one incentive layers, but on SON we don't have that. Blockchain, as Lipsa mentioned, that's nothing but it's a state of machine which gives you kind of information, and JSON RPC. So it's a communication language, better to say. It's some protocol which help us to communicate the information. Now, okay. So now will this make sense? I've just given you some terminologies with the analogy of politician. So now if you request some information, you need to validate your identification with the signer part, then front end will front end will help communicate with the provider with the help of some JSON RPC. So this provider is like, as I mentioned, there's a few third-party vendor, and you can set up your own system as well. But set up on system may cost, but it depends on the needs. So a smart contract is nothing but your business logic you want to execute with the EVMs, and those information is stored on the blockchains. All good till now? Shall I proceed?
OP here.
Yeah.
So what is the major role of provider here? As I know that in blockchain, if we see example of some cryptocurrency, so this will, if provider comes into picture, then that application may become expensive to the user because of provider in the picture, because they will keep on getting the commissions.
So actually, as Lipsa mentioned, the cost is again a big concern throughout the Web 3.0. That is the one key point which is not, it's not acceptable widely. But what they do is they also reward the user. So suppose if you are aware of this browser, Brave browser. So if you use this particular browser, it will give you rewards as well for browsing. So they have the some concept of rewards as well. So when this providers comes to in picture, they will try to give you something in return. So as today, whoever is going to fill the feedback form, we are trying to give the NFTs. So
yeah, just to add on to what Bobby was like, what the question was, right? The provider has a like cost associated with it, like a service has a cost associated with it. That's, I'm assuming, what the question is. So you should understand most of these providers, like let's say for MetaMask, is an organization that does not really make a commission at all. It's just a plugin that stays and authenticates and works on the blockchain, because you can't really own the blockchain, right? So it just provides you tools, and most of the things that it uses are completely open source. So there are few service providers which you would use for your dApp or your application to sustain for longer, just like you pay AWS a little bit of fees for it to sustain longer. But almost none of it goes downstream to the user, not until he's doing a transaction, which has a transaction fee. And if you've ever swiped a credit card, I don't know if you noticed that, you actually pay 3.5% transaction fee. If you've ever tried using credit card to pay your electricity bill, there's a transaction fee, because a credit card or the debit card takes a transaction fee for online payments, so that the online gateways are in existence and keep working. Okay, so this whole thing is the same here. It's called gas fees. I think OP has it in the slides ahead. So yes, the fees are very high right now because there's a hype behind this, but once this stabilizes, the fees will be almost negligible or close to what we see in cards, or even less. There is a current coin which has a smart contract system where the fees are like 10,000 times less than what you would pay a credit card company for transactions.
Okay.
So I can add some similar example, like when the mobile technology or the this facility of mobile games, the providers are charging something like 18 rupees per minute for a particular call, and for incoming also they are charging some similar 7 rupees or some. I have used that so long, but nowadays it's almost free. So you need to just go with the flow. So it's something like this. So
One
okay.
more time.
Yes.
Can you go back to the slide?
Yeah.
So I see the smart contracts are like business logic, right?
Yes.
They're getting executed on the EVM.
Yes.
So this architecture looks like a centralized for me, right?
So this EVM is distributed on the various nodes.
Okay, so
Actually,
I mean, if there are 10 members, all of them will have this common EVM.
Not common, but they have their own EVMs, and which is able to process the information.
Got it.
Yeah. So if we go with this diagram as well, currently I'm just representing a small block of backend, but you know, as a backend as a developer or architect, that there is ultimately a large number of instances which is playing the role of backend, and they might be have a multiple front end units as well, which is taking care of, might be a multiple instances of database. But just to make the things simple and what to say, to cover in a single diagram, we have trying to represent in this manner.
Got it.
Yeah. So let me jump to the next part of it. So as Lipsa mentioned, there is a problem with the scalability and what these graphs are doing here. So I will take you to this particular slide, website, better to say. So this is nothing but it gives us information how the things are taking. Say suppose you want to go with some identifier, like how the rewards are going on or how the fees are like that. So you can identify like this is nothing but 5th of March. Let me go the yesterday. So total blocks for yesterday is 6,331. So which is huge. But when here it's like very less. I don't know why, but there's a lot. It's costly stuff. So we also need to think something around the scalability part. Say this gas fee. I think Rahul was mentioning some time back. So it's quite high. Say in the date, I think I may December 8, 2016, and average gas fee is 939.58, which is like too much. And here, so as Rahul was mentioning, over the time it was going to be adjusted. So in the era from 2018 to 2022, there's a big difference here, right? So in the for yesterday, I think it's nothing but okay, let's consider for 940, and here is 900 something. So you can consider the difference. So That's the one thing I like to highlight. So scalability is a problem. And let me tell you how there's no perfect solution as of now, but people are trying to put some approach. So building a DApp on Ethereum with a high gas fee is a bad user experience. So ultimately, one of the provider known as a Polygon, so they have a concept of sidechain, but I'm not really focusing much on the scaling part as of today. So Polygon, what they do is they have the concept of side chains. So whatever the processing is needed, they do on the small units, side, typically known as side chains. And once they are done with the data, they publish it to the main chain. There's other solutions as well, optimize rollback and JK, sorry, not JK, ZK rollups. So consider for this scenario, every bank needs to submit the data to RBI, in at least in India. So what they do is they do not submit the data of OP, Rahul, or some other person individually. They submit the information based on the like collective information. So they process for their monthly stuff or weekly stuff, whatever the format is, and they submit their data to a RBI. So consider that particular analogy as this. So this is RBI, this is the small banks, and this is a data of say month wise or quarterly, whatever they say, consider a quarterly. So they will update that information on yearly basis. So in this way, the maintenance or the efforts are less. And if RBI needs any particular set of information for ABC reason or specific to user, he can always able to query it. So yeah, so the graph is one way to query. I'm not going to cover that. Similarly, if we go with the scaling solutions, the Polygon I mentioned, ZK rollups and optimized rollups are the few key terms. So I think I should stop here just to give you a kind of hints what are the system currently lies in. So we are on the edge from 2.0 to 3.0, and we are trying to utilize the stuff. We are trying to solve the problems, and I think Rahul can help us more. Let me once jump to the chat window if somebody have something for me. To main chain and Solar is the good condition for labor Solana. I think the layer 2 solutions such as Polygon already lowers the fee of yes. So Suvarna Das, yes, you are correct. So Polygon is kind of helpful because I mentioned in my one of the previous slide that okay, sorry, yeah. So they just do their business on side chain and aggregate the information on blockchain. So I think I should hand over to Rahul from here. Rahul.
Sure.
Yeah.
Hi guys. So I will be using my whole screen. I do tend to draw and explain and do a lot of crazy things. My name is Rahul. Let me go to my slide. Yeah, I'm sorry about that. So we'll start off from there. I'll try to demystify a lot of things that are terms which are actually pretty simple, even some cryptographic things. Okay, so yeah. So have you seen Web3? I mean, I guess if you are in this meetup, chances are, even if you have come here searching on a meetup for a group for Web3, you have not seen Web3. And that's going to change today. Today, I'm going to make you, like, I'm going to show you how to install MetaMask, how to work with MetaMask and actually use dApp applications, because any applications that are built on the Ethereum chain, okay, or the Ethereum, what we say, smart contract system cannot be accessed willy-nilly from the web. And that's what, whoa, that's not the slide. Okay. So yeah. So these are the few questions. How can I start building an app or dApp on the blockchain? Wait, we don't need a database. Yeah. Where will my Instagram stories go and will I be hacked? Most probably yes. So be careful. There's a lot of crypto scams going on. Okay, what is MetaMask? What is EVM? And this very famous quote from Elon Musk: has anyone seen Web3? I can't find it. So for most of the industries divided between these two groups, right? One, everyone says Web3 is the next hype. People have forgotten that we had the semantic web really never worked, and we moved to the new definition of Web3, and like we're still at it. So I won't make any predictions to put all of your eggs in this basket and become the next Web3 developer. Although Web3 developers are paid highly. Like if you know how to develop on Web3, you can get up to 70 to 60 lakhs even in India. It's like a ridiculous amount of money, right? Especially in the Indian economy per year. So yeah, Web3 developers are sought after because it requires a little more level of knowledge compared to your normal developer things. Okay. So who am I? My name is Rahul Mohan. That's my Twitter link. I'll share it in the chat. You guys can come, follow me on Twitter. I'm very active. I keep tweeting about web and everything that has to do with web. And what do we do here at Talentica? Like, and that's a point I wanted to cover. We are like a bunch of really talented folks. I mean, there is a lot of bad rep that goes around with like, service-based companies and stuff like that. Trust me, this does not feel like a service-based company. I'm working on the cutting edge. I think OP is again doing crazy things in his project. Same goes with Lipsa. Like we are all working on cutting edge, sometimes even better than bigger companies. And I would argue like even really big giants. So very interesting. Do visit our career page. I think maybe OP can share a link to our career page if you're interested to work with really good folks. We do a lot of interesting things here. We have a good company culture, and so that's why I'm here on a Saturday doing this, right? So yeah, before we even start off, right, a show of hands or anyone who's confused. Do you guys even know like what is this hype about blockchain? Like in simple terms, like what the hell is a blockchain, right? And how is it so secure, right? Is like, do you guys have any idea? Like, is there any what do you say? Any layman explanation you guys can think about of why it's so safe? Okay.
Because of the cryptography picture.
Yeah.
And all.
Yeah, the crypto, you were saying about the cryptography.
So every transaction is hashed and cannot be tampered.
Cannot be tampered with. Okay, so but what does this really mean, right? Like it's a technical term. So I'll give you a simple example. Okay, so you guys, it's going to be a little what do you say? It's going to involve human bodies. Sure. Okay, but it's okay. The reason I'm giving an example like this is very memorable. So I remember learning, and one of the mentors who actually taught me like this, right? So assume you're a human being, right? And you have breakfast, lunch, dinner. Okay, and assume with breakfast, lunch, dinner, you take this very specific pill, okay, which does something to your whatever you have consumed, right, every day. And you know what happens in the morning. I don't want to go into details of what happens in the morning, but you can say for sure that based on what you're eating, what comes out in the morning is totally different, right? Everyone has an experience of this. This is what essentially a hash function is, right? What a hash function is we know for a fact, okay, and yet it's not mathematically proven 100%. It's called the PNP hard problem. It's also called the millennium problem. If you can prove that there is no possible way to find the original values using the hash, mathematically, you get $1 million. So why not, right? It's called the millennium problem. But then this is what is happening. So you eat breakfast, lunch, dinner, and I'm assuming based on what you eat, something else comes out, right? And if you eat consistent food, what comes out is consistent, right? But you cannot determine what you ate based on what came out. And that's what a hash function is. So instead of a human being, it's a function where you put data in and something comes out, and we really don't know how this came. Like if you give this to someone, they can never say what you ate. Okay. And you know how the blockchain is built? I told you about the secret pill that you take. This will slightly change the composition of what comes out or what comes out in the hash. And this is what a Bitcoin is. So what happens is whenever a block is mined, okay, what happens is transactions are put. This is like eating breakfast, lunch, and dinner, okay, that you put in your hash function. And along with that, the miner who is just trying to mine the block puts a transaction to himself. And you should remember all of these are just transactions. It's like saying Rahul paid OP 5 rupees. OP paid someone else 10 rupees and XYZ. So all of these things keep on piling up. At the end, just add, I pay myself 1 rupee because I did the transaction, I did the eating to figure out what comes out next. So that is what represents a Bitcoin, that is what creates currency on the system, right? Now, what happens on the chain is every time you have another block of transaction to be processed, you take this header, and there are some mathematical reasons to make this hard. Okay, it's like saying example of it would be, assume you give these pills out in a bottle, okay, and it's a bottle of randomized pills that would just produce interesting outputs of the human body, okay, and there's one particular pill that would produce a very unique output based on what you had, and you cannot really determine it because you can't really just say, okay, I had this and I had this pill, thus I got that, I had this and some other pill, I got that. You can't determine because that's how human body is, or that's how hashing functions are. It's a one-way function. You put something inside, shit comes outside, and then you cannot really decipher it. It's called a hash. Okay, so you can't really determine which pill would give you that magic number. And in terms of Bitcoin, it's actually first 20 bits as zeros. Okay, if the first 20 bits of a hash is zero, it's considered to be a Bitcoin. I think it's first 20 zeros. I don't remember if they changed it. Okay, so assume there's a population, everyone taking this pill and checking if they got this special hash. Okay, and there's you who's malicious, who's like, I want $1 million, and you put yourself in the transaction saying, I want $1 million, and you want to beat this system, right? You will have to hire a lot of people to have these pills and like give out hash, right? So you will never beat the world. If the world has 7 billion people, you can't just generate 7 billion people to, make your new hash, right? That's why blockchain is so safe, because it's so hard to find what comes out of a hash function mathematically, yet it's not proven to be wrong or true, that it requires a lot of computing power to do false transactions. So even if China tomorrow decides to use all of their computers to beat the transactions, the rest of the world can say no. And it can't do anything about it, because China can never outpopulate the world until they go out on a war like Russia is doing with Ukraine right now. So that's what I'm trying to say. Like, that's why blockchain is so efficient. It's because of this beautiful thing about a hash function. It's a one-way function, right? So this gives us a lot of advantages. You can say Rahul sold property to OP, and that would not be a fraud. It would be impossible to do a fraud in that transaction because, one, it's visible to everyone. The blockchain is distributed, it's visible to everyone. And then there is no way to dispute it because he definitely found the hash and the whole world agrees to it. So that's why there is an inherent sense of security when it comes to the blockchain. Okay, now the example that I'm going to show of a DApp is an insurance company. Okay, so someone, because I'm too bored speaking myself, okay, can someone tell me what an insurance company usually does? Come on, speak up, it's okay. I'm not going to go into more human examples, right? So can someone tell me what usually an insurance company does? You pay your health insurance and stuff like that. Anyone can come
It
forward.
sells you policies based on a premium. It would sell you a term plan, health plan, retirement plan. So
Perfect. And what do you usually pay? You pay a monthly premium. Assume let's pay 1,500 as a premium, right?
yeah.
Cool. So a lot of people pay this premium, and based on some particular conditions, for example, you got sick, your house burned down, and stuff like that, you're given back some money, some lump sum, which is assured to you, right? And anyone who ever gone to a hospital with your Medicard or whatever medical insurance you have knows how horrible it is. Everyone agrees to that, right? Because one, you say, the doctor says, you need a laser surgery. And the insurance company says, laser surgery was not covered. I'm like, when was that not covered? Oh, we removed it last year, right? That's what insurance companies do. That's why insurance is a scam. It's been a big issue for ages. Same goes with car, same goes with all of the other institutes that you can think about. Now, the beautiful thing is you can actually build an insurance company without any human being, which is the biggest problem of insurance companies, and just give the creator a small reward for creating this on the blockchain. and it would be completely automated. So how it would work? So it works on this special thing called a smart contract. Okay. So what a smart contract is, it's just code that you have written. I will show you how to do this because there is demos in this, like the presentation we are doing. Okay. It's a smart contract which is very simple. Okay. Take money. Actually, it can take money by default. A smart contract is like a human being. It can actually own crypto. So smart contract is just like some other human being buying crypto. You can just like you can have money in your wallet, a smart contract can just have money in itself, in its state. Okay. So the smart contract will say, okay, I know that these 25 or 10 addresses, let's just say 10 addresses, okay? 10 addresses are paying me money every month. If they don't pay me money, I have a list of people who pay me money, throw them out of the list. Okay. They are not paying insurance, they are not covered. Okay. And then because it's a program and it's not biased, assume you fall sick. Okay. And we will come to how that would be detected by a smart contract. But assume you fall sick, you go to a hospital and show your card, and it would know because it's a program. As soon as you show the card, it would recognize, okay, you are actually sick, and it would give you your amount, which is assured. And you don't have to talk to a single human being ever. And insurance will work. And that's the beauty of why people are going crazy about Web3. This is possible. You can build entire industries like this. You can literally build a shipping industry which has almost no human interference. Once it's deployed to the blockchain, you just pay the fees and you will get things delivered to your house. Okay. Another good example of something that I heard recently was they were planning is a hotel room which has no staff. You just go and swipe your card and your card is linked to your wallet. It would just take money, and that would trigger the smart contract for the room in question and activate all of the lights for 24 hours, lights and plumbing and whatever. So it's brilliant. It's basically what we do every day, that is programming, but integrating it into our real lives. So it's actually pretty interesting. Okay. So till here, anyone has any questions? Like, this is a very basic example. I'm assuming I can proceed, right?
So Rahul, here in insurance case, there is a possibility of scam from the hospital side.
Yeah, so that is true. There is a possibility of scam from the hospital side, right? Yeah, because and that is another problem. We'll actually discuss it. So it's solved using something called oracles. I had a cool PPT for it. Will come later. So here is the thing, right? Let's take an example of a hospital, right? Assume a hospital sends blood samples, right? Saying that this guy is sick. It has to prove it's sick somehow. So it sends blood samples, and what it does is it pays hush money down the table to another guy saying, boss, say the results are positive for COVID. I want my guy to get insurance. He's giving me 30%, right? That's the kind of scams that can occur.
Mm-hmm.
So what actually happens is, instead of that, we distribute that system and push that to the blockchain as well. So when he publishes data of the results that he have, he cannot use any service. He will have to use some service that is globally recognized, like a blood recording service. And not only that, we can even do things like we can validate his data with pre-existing data and have another whole blockchain running to validate medical records. And that is what oracles are. It's basically a parallel blockchain running with real data that would actually ensure that your data cannot be fake. Like, you cannot do scamming there, because always understand, scamming here works because one guy is saying something and he's trying to force the whole world to believe it's true, right? But what if you give incentive for other hospitals? For example, pay them a small fee for validating validating prescriptions on the network. So now there are 30 hospitals on the network, right? And this guy says, based on a report of oxygen level to some 98% that he has COVID, all of these hospitals deny, saying, no, that's not the case. And because they are actively contributing to their blockchain, which is another blockchain, they get paid in crypto. So they will not deny to it. And the reward for these guys is far higher than whatever this guy receives. And he can't keep paying everyone off saying, please show fake data. That would not be profitable. So we distribute information collection as well. Has this been done in extensive manner? No, it's really hypothetical. There are very few oracles at work. There are oracles for news sites. There are oracles for stock prices and stuff like that. And we will go into some of those. But yeah, and another example of an oracle could be, for example, if you have house insurance, that would pay you out money for your house flooding. The assumption is the house floods, a lot of houses flood with it. It's not like suddenly तुम्हारे घर के नीचे बारिश हो गई and your house has flooded, right? So what you would do, you would along with the insurance, you would force them to place this rain water centimeter thing, to be fitted to their house, and anyone who fits to their house again gets paid because they are actively participating on the blockchain, right? Because they are giving data to the blockchain and they are paid in tokens. Okay, they are paid in tokens. So even if this guy's sensor says it's flooded, you know he's scamming because he just poured water into his sensor, right? You know for a fact that it's true because it's distributed information. That's called oracle. We'll come to it. But I think that clears that out, right? Is there any other questions? I'm assuming, sorry if I'm going very technical, and is there something that's going on top of your head? Yeah. Any other question, guys? Can we move forward?
Can you give one more example of a smart contract?
Okay. Smart contract. Yeah. Okay, good. You guys have heard about NFTs. I'm going to give you NFT today. So then, yeah, have you heard about NFTs? Non-fungible tokens. Okay. So if you have seen news, there was this meme cat. If you ever have seen this meme cat, it's a cat with a rainbow coming out of his back part. It's called I think it's called the meme cat. I don't know what it's called. Rainbow cat, something like that. This sold for how much? $350,000. Yeah, I think so. Yeah, for that amount, right? For that amount, I think so. Please don't quote me on this. I don't remember the exact price. And I'm not talking that this was the only copy. Everyone has this meme. I can show you this meme right now. Okay. And it was still sold for someone for some reason. Okay. So another example of what we say, this is the NFTs and how do you work with NFTs? Have you ever seen a vending machine? Right? You've seen a vending machine, right? Vending machine, you click on some buttons and a chocolate pops out, right? Yeah. That's what a smart contract essentially is. Some conditions meet from outside. I dispatch out something to you, and whatever I dispatch out to you is for everyone to see. Everyone in the world knows that you own this now, okay? Because you clicked those buttons. And like that's essentially what a smart contract does. So another example would be, you can make a smart contract that prints out NFTs, okay? So what you would do is, you would say, okay, when any user puts money into this account, which is about 0.005 Ether. Okay, Ether is the currency on the Ethereum blockchain. Okay. So if you put 0.00 Ether, what I will do is I will use all of the SVG images I have collected. Okay. Maybe it has an image of a spiky head, maybe it has an image of a guy with this hair, and then there's a head with smiley face and sad face and whatnot. And then there's a body with a triangle and a square. And I mix and match and make a unique pattern and send it to him. Again, I make a unique pattern with this. And then I take the hash of whatever that image has been generated, put it on a more stable source than a blockchain. We'll discuss that. And then say, okay, now the user who created this contract, his ID is always unique. Assume it to be like Aadhaar card number. Dot some random image he created is now owned by Rahul, and i.e. this is non-fungible. There can never be another copy of this exact thing because this image has been uniquely created and it actually is just a hash, and this user is unique and now I own it. So that's another example. It would just put out this data on the blockchain saying, okay, now everyone agree to the fact that Rahul Mohan owns this crap. And I can go to my website and see, okay, now I own the NFT. You guys can see this too today. Like I'll actually share an NFT with you guys. It'll be fun. Maybe that clears what I'm trying to explain. I don't know.
Yes. Got it.
Yes.
Thanks.
Okay. So yeah, cool. I will just move like this because I don't want the full screen. Okay. So yeah. So insurance and stuff like that. So now we come to the actual nitty-gritty of like what we are trying to build on the blockchain, right? Or like in this case, smart contracts, whatever, right? So first thing is, usually let's go to something on the web 2, right? Let's go to something on the web 2. I have all of the links here. So let's go to something on web 2, Facebook. Yeah, don't judge me for my posts. I don't really use Facebook. Okay, I'm more of a Twitter guy. So yeah, when I log out, and hopefully I remember my password, you guys clearly can see, and I'm assuming my screen is visible. Okay, my screen is visible, right? I'm not just talking. Yeah, cool. So I put my username and password in. Obviously not show you guys because then I would have all kinds of memes being posted on my channel without my permission. So I do both of this, and Facebook says, yeah, that's Rahul, okay, and logs me in, right? We don't want that because we don't want Facebook to store any data. We want every data to be public and fully anonymized, right? Now, once I log in, Facebook knows what we say, that I went to ilikecatch.com and then suddenly I'm going to some other site, or I'm talking to you about blockchain and suddenly, or you guys are in this, and because our phones are listening to us, you get ads of, you know, buy Ethereum for 50% off and things like that, right? Which is like this bad, right? So that is the kind of system we are in. We remove that, okay? So the first thing, the first link is to authenticate who I am, or to uniquely say, this is Rahul Mohan. And you guys will need this to redeem the NFT that I'm going to share at the end of the course, at the end of this meetup. So go and search for MetaMask. MetaMask is an extension of Chrome. Okay? Go to MetaMask, go search for MetaMask. Okay? And actually, let me go through the process of actually getting this. I'll delete my, okay, there's something very important. So as I told you, Facebook or no other server remembers. MetaMask is not a server. It does not remember who you are. So now when I log out, okay, settings, yep, I want to log out. Wait 1 second, guys. Let me just uninstall this altogether. Manage extension, remove extension, remove. Okay, so all you do, press download. To get access into the crypto world, you can't access any dApp without this. You need any wallet like this. You need like a wallet that's usually supports Web3 and stuff like that. Okay, we'll come to that. Okay, so I press download and yeah, what? Come on, guys. Add to Chrome. Yes, I would like to add to Chrome. Okay, so yeah. So as you can see, MetaMask has been set up. Yeah. So MetaMask has been set up. It says welcome to MetaMask. Good animation. Cool. As I get started, and I say, so there are two ways to access. No, I have a recovery secret key phrase. So as I told you, there is no human possible way for MetaMask to give you back your ID if you lose it. So don't lose your password and keep your secret super secret. That's why I'm creating a new account and not showing you my secret because I have some Ethereum on there, right? So I say, okay, we never collect IP addresses. Okay. So you put a password, and because I'm smart, I'm going to put test 1 2 3, right? Test 1 2 3 4 5. Okay. Wow, I can't even do that. Yeah, I have read. No, I'm not. But anyway, you click that, create, voila, and you're ready. Okay, you are in the Web3 world now. So you go to next. And this is important. Okay, I know you guys will all abuse this wallet, so I'm not going to show the secret key. It'll say for you to save your secret key. So you click here and write this down on paper. This is your grand password. If you forget this, no one can recover it. Okay, so don't do transactions. Okay, because there is no. Yeah.
Is this the secret key?
Yeah. It's like a 6-letter random word. It says fox jumping over clouds, vagara, vagara. So it's basically a list of characters that generates the secret key, not necessarily the secret key, because secret key is hard to remember, right? So what they do is they have the simple function where if you put a particular set of characters in, your secret key would pop out of the function, and they keep it long enough such that there will be no repetition till the end of the word. So yeah.
So it will
So
be
you remember
unique for each member?
Yeah. Yeah, everyone. And you can uniquely generate a secret key using this text. Every combination of this text generates a unique secret.
Okay.
Yeah.
I mean, if say suppose two people put the same sentence, they'll have the same secret key.
Yes, and that's dangerous, right? Because now you have access to my account, right? So yeah, that is true. So don't show this to anyone. I'm using a demo account and I'm still not showing this to anyone because there's a lot of crypto scams and I don't want to get involved in all of that. But not that I would be tracked anyway. Okay, this is just a hash anyway. Okay, so this is the secret key. This is the secret key in end-to-end encryption that you use. This is the secret key you use in symmetric encryption. This is the secret key that you should not be telling people, or it generates the secret key. Remind me later. I'm not going to care. This is a side account. Okay, and you get an address here. This address is your address for eternity on the blockchain forever. So any transaction you make, you can trace it using this address. This address is unique to you. Okay, and this address can be obtained again by putting the secret key in if you, for example, lose the browser or something. You can even install apps that use similar thing. I'm not sure if MetaMask has an app, but there are similar apps that do the same thing, create a unique account for you on the network and stuff like that. Okay, till here clear? Simple. It's
So
like
there is no requirement of email as such during
that's the thing, right? Blockchain is completely decentralized. You know who I am? I am this random person. I'll share this with you guys. Okay, so anywhere in the world you can transfer money to this whatever garbage that is, and I would get it. There is no email, there's no traceability. Why do you think governments are scared? Because it can topple governments. That's why. That's the reason why people don't like crypto. It's completely decentralized. The power is in our hands. Like, see, I just created an account in front of you.
Okay, so this is one wallet which is created under MetaMask.
Exactly. And the secret key generates that wallet. That holds the secret key to that wallet. Yes. This is a unique wallet generated for you. Yes. Right? Good? Makes sense? Wallet is just like an email address, but more safer because it does not usually have your name on it. That's my email address in the crypto world. You can think of that like that. So if you want to redeem your NFTs, all you need to do, install an app called POAP. You can search for it on Play Store. And in that, just put this unique hash that you generate from MetaMask. Okay, I'll just show you the site and share that. POAP. POAP. Okay. Go here. They'll tell you the link. Okay. Oh, MetaMask has an Android and iOS app. So yeah, great. So just download this app. If anyone hack my browser, can they make transactions using my MetaMask? Depends on the hack. Like if they have full control over extensions, yes. If not, no, not necessarily, because it'll actually ask for explicit user input every time you do something. But yeah, it is a little risky. So keep it maybe in your phone, or like other people keep it in like a pen drive. So that's what I do. Keep it in a pen drive, keep your wallet in the pen drive, away from the internet, disconnected, like, hang it around with you. But yeah, it is possible. If someone gets access to that, yeah, they can do malicious things. Cross-site scripting is still an issue here, so yeah, be careful. So again, install this app. This is how you redeem your token. I'll also show you how to redeem your token. Okay, I will send you unique. I'll send you unique. What we say, addresses. Okay, I'll send you unique addresses, and if you go to these unique addresses, which you will get through mail, all you have to do. Okay, the address pops up, and you have to put your Ethereum number address here. So you just have to put your Ethereum wallet that you just created here and say mint a token, and you have your first NFT. So yeah, it'll be stored in your wallet forever. So just make sure you put your address there. So in my case, it would be this. I'm not trying to mint this to avoid reminting. I've already tried and it works. But anyway, let's just mint this.
What does mint mean?
Okay, mint means an NFT in your name has been created. So what will happen is the Web3 Meetup Talentica has a unique hash. as a user, as a wallet, okay, or as a contract. That plus whatever hash I put right now creates a unique token for you, which is an NFT, and it will be there in your wallet forever. So for example, once I do this, voila, my first NFT. It'll take some time because it's actually processing it on the chain, right? It's not a free transaction, right? So yeah, it'll take some time. So anyway,
Rahul, I had a question. So MetaMask generates a unique address, right? So doesn't ZepPay and WazirX, these wallets also create a unique?
They do that. They do that internally to abstract it away from you. But I hate platforms like that because they take the power again from you, right? They are still centralized apps. They do create unique addresses, and you can actually transfer, but they limit the transfer, which is crazy, right? Because but yeah, you can actually move those wallets in here as well. You can use that wallet address to initialize this, yeah. But usually they don't give interfaces for you to push it out. It's hard. So yeah.
Okay. So I do remember registering to ZepPay, and it did collect email addresses and a few other details.
Exactly.
Yes.
That's bad, right? That's bad. They are a centralized company. They are here to make money. Web3 is not about to make money. Web3 is about like giving power back to the user who created the content that companies are profiting on. Okay. So that's a minted NFT. What I mean by a minted NFT, if you go anytime on the blockchain, you can actually look at the transaction the day. And by the way, guys, this will only be available till tomorrow. After tomorrow, you can't mint this. Okay, so there is a time restraint. That's how I build the contract. So the contract is built in such a way that after tomorrow, there will be no minting. So as you can see, this was my first minting example. You can actually, if you have MetaMask, you can actually open this on any trading platform and actually sell this as an NFT. It's like a valued NFT. So yeah, interesting. Okay, this does not work. The service does not work. Okay, these are all dApps that I'm communicating with. And as you can see, no matter what dApp you go to, in your tags, you always have this POAP as proof that you attended this event. And it's an NFT. There are only 100 of them. And how many ever are minted today and tomorrow will be the only ones that will ever mint and be in existence. Whatever. Okay? Cool. Interesting. Cool. I just wanted to do this because I wanted to make a little more interesting way to do these things, like real life application. People talk about technical things a lot, right? So let's go back to that. So now everyone knows what MetaMask is. It just does authentication, right? It's not that hard to do. It just does authentication. It's like Facebook. I just have to log in once and remember forever, for eternity, whatever. Until you delete your browser, then you have to use your secret key to load it back. Okay, so be careful. Whatever that secret key comes when you press unlock, write it down on a paper, save it on a pen drive, and put it in a locker or something if you're ever doing transactions. Like make sure no one sees that because it's your secret, right? So yeah, that's MetaMask. Now front end. How would a front end of a Web3 application look? No different from any other front end. You can use React. That's what I work mostly on. You can use Vue. You can use HTML if you are crazy. Why not? Right? So you can use normal HTML and you would require JS. Okay. And then there is this one thing floating around everywhere called Web3. Okay. Let me demystify Web3. It's nothing fascinating. It's just a simple, very simple concept. Kuch nahi karta. Okay. What Web3 does, okay, and I forget to always close my annotations. My God. Yeah. So what Web3 does, Web3.js, it's a library. What it does is, I'll show you something interesting. The moment you download MetaMask and you go to console and type window.ethereum. Whoa, what is this? This is basically a huge object that lets you do transactions from now on. And that's what OP was talking about as a signer. The signer is like these tools that lets you sign transactions saying, oh, Rahul Mohan is the one doing this transaction and come on blockchain, accept that I am doing this transaction. Okay. So you can actually build an application without using Web3 and just JS. Okay. That would be some hardcore crazy shit. That would be like doing, machine coding when you have C and Java, but then you're crazy. You have all the choice to do that if you like. But if you're not crazy, just use Web3. It's very easy. Like, you know, just go to the documentation. I don't have the time to sadly cover. If there is a lot of interest generated by this, maybe the next meetup we can actually cover how to actually use Web3 and stuff like that. But Web3 is just a simple library where you can just say, oh, sign the transaction, like, you know, make a transaction of X amount, like make a transaction of this, and your MetaMask would be able to communicate with your browser, and like, you know, the user will have a seamless interface. Okay, let me show you this in action. Okay, wait, let me show you this in action. So if you go to Ethereum, okay, this is their site, pretty cool, and go to user dApp. These are dApps. These are applications that are distributed over the blockchain. And let's go to a simple one that everyone usually media goes crazy about. Okay, so let's go to arts and collectibles. Yes, OpenSea. Yeah, OpenSea is a very famous one. So you look at this. I'm currently in OpenSea. OpenSea is a website. Does this look any different from the websites you've seen in your normal lives? Pretty normal, right? Yeah.
Similar.
Pretty similar. Only difference is when I go to login here, where is Facebook login? Where is Google login? There is no Facebook login. There is no Google login. And they don't even have data for you. Like, they don't store anything about you. The blockchain does. So when you click on this, what it's essentially doing is, now my wallet says, okay, are you sure you want to allow OpenSea to like use your, what do you say, private key for doing business? And I say, okay, I'm cool with that. And suddenly I get all of the history of the things that I've done. In this case, is a freshly created account and there is nothing. It also shows me the Ethereum that I have, which is nothing, and all of the NFTs I've collected and everything. The thing is, usually on Facebook, the data of your profile comes from Facebook. Can someone think about where this data came from? Because OpenSea does not really connect. Like, does anyone have any idea where all of this data has come from?
Blockchain.
Yeah. All of this data is stored on blockchain or any of the file systems that we use for blockchain. So it does not have your data. You just told, okay, I am this random person who you don't even know her email address of, and I would like you to aggregate all of my data, okay, and just show it to me in a beautiful page, and then I would like to buy some NFTs. So you can just go ahead and buy NFTs now. You can do transactions without taking out of your card and putting your CVV and all of that crap. You can just go, okay.
Is it possible that OpenSea can store our data? Because like, say suppose, you know, like for Netflix, right? It's better that they store our data because they can recommend some new movies, right? Over there it's beneficial. So is it possible?
Exactly. I mean, they can try to, because they can like sneak in JavaScript things to do that, but you should understand they can't, because you can just look at this code. You understand, right? All of this code is also on the blockchain. So OpenSea is not lying on some private server behind Facebook walls, right? Where you can't go into the server and check the code. You can literally go to the blockchain like elements or the code or like the smart contracts on which OpenSea is written and check if it's collecting data. Where else would it store data? Because all of its logic is processed by the blockchain, right? There are no servers. You understand what I'm trying to say?
Got it.
Yeah, so like it's like open source software. Like if think about it, some open source software suddenly starts collecting data like Firefox, you can just go to their repo and like fork the repo and like, nope, no pride out of that, right? So similarly, all of these are just smart contracts running in the public. All of this code is public, right? What MetaMask is doing is just aggregating all of this and like doing transactions with that contract. That's all. And OpenSea is just showing you like whatever is again there on the blockchain, right? I'll show you an example of this. So, but does that make a little sense, maybe?
Yes. Thanks.
Yeah.
Yes.
So then all I have to do is just press pay and add funds and problem solved. I have this weird ass painting that costs a lot of money. I thought to buy that. That's why I didn't get my real wallet. So that's what dApps are. Sometimes I get distracted. Yeah. So cool. So that's what the front end is. Front end is
How do you add money to your wallet?
So you can, that's where there are issues, right? To add money to your wallet, you will have to either go through a normal financial mean, which is like, you know, like
Payment gateway.
some payment gateway. And that's where the traceability is an issue, right? They can just trace where this original wallet was loaded. And because government is government and they're forced PAN card to be included in any wallet to load money into a wallet, they can track you. But the eventual idea is it'll become so ubiquitous, like it'll become so common. You could just pay money like physically to a person who's living next to you, and he has some like Ethereum lying around. He's like, okay, I'll transfer it. And so that's basically what it is. It's gonna.
That's the news about tax being implied on crypto purchases.
Yeah, that is
because they could track your payments.
Yeah, so basically they want to discourage people holding money there because blockchain, like cryptocurrencies are a good way to avoid inflation, because if you want your money to actually go up and not like, you know, be dependent on a government doing a war or not, right? For example, the ruble is a good example. Russia went on war, their currency is worth half the price. So if you had 50,000 in your account, after the war, 3 days later, you just have 25,000. Think about that. Crazy, right? Doesn't happen with crypto. So, I mean, does happen because of the price fluctuation right now, but once it stabilizes, there's no government that can control it.
Right.
Kind of a good thing. Better than government control. So yeah, right now the only way is to actually go through legal ways. But in my case, once I buy something, I never actually pull it out. So the tax is only applied when you pull out and transaction back to rupees. So I just hold my cryptos. I do transactions using cryptos. Some companies do accept. So yeah, that's done. You can even buy a Tesla using crypto if you're wondering. Cool. So yeah, so front end, we are done. We're done with the MetaMask analogy. Front end I explained in some degree. Now the back end. Back end is interesting. Back end because I want to show you the smart contract and like demystify this a little, right? So yeah. So the most easiest way to start working with the blockchain is to use this thing called Remix Ethereum.org. Remix is an online editor for you to make smart contracts. Okay. Now I know. Wait, one second. Where is the simple one? Your story. Let's take the most basic example, right? So all I'm doing is storing a single int, okay, and then I'm writing a function to retrieve that int, and that's about it. Okay, so there's a way to retrieve it. If you look at this, someone has seen Java, might be very similar to their experience in Java. Contract is essentially a class, and that's how it is treated as. That's why most dApps are quite object oriented. This is literally some like uint actually means
unsigned
int.
Yeah, it's like a positive number. That's all, right? So and it's a 256-bit number, and because it's public, you don't need to write a get function. You can just publicly access it, and there is a function called store that actually stores it. Okay, this makes sense. Very simple program, right? Cool. Now let's actually build it. So first you compile it, like you compile other languages. Once you compile it, you can see their options here. Okay, there's a way to actually deploy it, quote unquote, because deployment actually requires cost. Because you're deploying a smart contract is adding something to the blockchain, and adding something to the blockchain requires everyone to come and say, okay, we agree to this. So you have to pay something called gas fees. It's like paying AWS money to like host your website, right? It's very similar to that. So that's there. So instead of doing all of that and paying the exorbitant cost of Ethereum's currency, like conversion rates, I can actually deploy it to the virtual machine. So virtual machine, it's like a completely blank system where everyone has 100 Ether. Look at this. All of these profiles, very similar to the hashes I showed you guys, right? If you look at this, again, check out this in the chat. So remember the old hash I shared with you, that and this looks pretty similar. These are all addresses. Okay, so I have about 100 addresses. I think 100, right? Yeah, creates 100. Oh no, not 100, some X amount of addresses. Okay, and I can just say, now I want to deploy this contract. and see carefully what actually happens. Okay, the smart contract did get deployed to the blockchain, and you guys might have seen here on the chain there's a new entity added, basically the storage.constructor. That is the constructor function of the storage ran on the blockchain in the virtual machine, which is a distributed machine that stores a global state and everyone agrees on. Okay, and the storage.constructor ran. It's just like a Java program. Okay, obviously the constructor ran. And then it was run by this dude, which is 053. And if you look carefully, I don't have 100 Ether anymore. I paid a gas fees. I paid a very small amount of fees to deploy this code on the blockchain. Does that make sense? Yeah, they were saying something. Someone was going to ask me something.
Rahul, so when you say Java virtual machine, JavaScript virtual machine, you deployed this on. So isn't this the actual blockchain?
It's Ethereum. No, it's not an actual machine. It's like an automata state. It's like a state which talks about the global state of everything, right? Okay. Not really a real machine. It's a virtual machine. It's like completely in the combined imagination of the chain. You can assume it to be such without getting too complicated to how it actually works. Right? So yeah, you paid some fees, just like you pay Amazon AWS to like upload your shit on AWS, right? And then yeah, you pay that fees and you're done. The smart contract is there, right? Now let's take someone else, okay? And he wants to interact with the smart contract. So how would he usually interact with the smart contract? Using Web3 or using some other website that has built some layers on top of it such that they're using Web3 to communicate with MetaMask. So that, you know, it says, okay, I am this user. So basically it'll say, okay, I'm this user, I'm signing as this user, and I want to do some transactions. For example, I want to store the data. Okay, I want to store the data in this int as 1000. Okay, it's just a state transition. Okay, when I press store, you can see there's a new transition on the network. Like there has been a new transition made on the network. And if you look carefully, a gas fees has been subtracted. Okay, so that's why the money concerns are there. That every transaction does cost you some small amount of Ether. And for Ethereum, it's very high because it's based on a very flawed system that we have moved out of. Right? And to prove you that this does exist and this is a decentralized, I can go to some other account and I can actually do test of, not test. Where is the get function? Yeah. Okay. I think I lost the get function. Yes, test. Oh yeah, sorry, test. If you see here, UNT data is the 1000 that I stored. So yeah, it does exist. I can retrieve data and store data. And you can understand, once you retrieve data and store data and you can put conditions, that essentially is a computer. So yeah, Ethereum is essentially a computer that can do whatever you want. So yeah, you can put wallet addresses here. You can build a, an example for, car ownership. You can build an insurance company on this. And I think you guys can understand that if you know any programming language, learning something like this, you could build. There is a caveat, okay? Unlike our failures on deployment, where we say prod bhatiya, there is no prod bhatiya. Once you deploy the contract is immutable because it's a blockchain, right? The contract is again part of the blockchain. So if you want to fix an error, you'll have to redeploy. And that's the beauty of it also. So if an insurance company has decided that it cover laser surgery, it can't do anything to change that contract. It can't go tomorrow and say, no, I don't support it anymore. The contract will still work and you'll still get your money. And that's why Web3 is so cool. I think maybe I've been able to give you some idea of why Web3 works. I don't know. Maybe.
Yes,
Okay.
yes.
So
yeah, I mean, they can again pay some fees and redeploy, right? If they want.
But then you are not putting money into that contract. You understand what I'm trying to say? Think about this, okay? So let's say I understood your problem, but like that wouldn't work. Only their new customers would be signed on to that. Old customers are still transactioning with a contract called some contract number. Okay, let's assume this contract, okay, that we are accessing right now, which is stored here, contract number 1. Okay, they are putting money into that contract, and that contract is who's dispatching their money. Okay, insurance company can redeploy, but then they can only sign on their new members to this new contract. The old contract is immutable till the end of time.
All right. Okay.
It's actually pretty cool. It's taking power back into our hands. That's why geeks and weirdos who sit with big desktops are so crazy about it. So yeah, chalo, let's move to the few other topics that I have. I don't want to go into much depth. I just want to give you an idea of flavor, because I know you guys are all competent developers. Most of you guys have done some development and you go back and try and test these things, right? That's what I want. I would like more people to use it. So yeah, backend is written in Solidity. This is not the only language. There are other languages. Hardhat and Truffles. These are two things that will actually development environments. It's like, you can think of it like as an IDE, but it's not such. But it actually helps you develop better code, because you can only deploy once and then only you can sign on people there. So it'll help you develop better code. And Open Zeppelin is another tool that actually lets you get proper syntax and contract definitions right, which everyone agrees to. Believe it or not, Ethereum's original version had a big flaw, and someone made a lot of money because of that, because their smart contract had a flaw. So that's what I'm trying to say. They couldn't fix it because it's immutable, because smart contracts are immutable, and that's the beauty of it, right? So yeah, so that's the example I'm giving here. Web3 dApp, okay, communicates with your provider, okay, and any known Ethereum providers. Ethereum providers are just systems that lie in between to make sure that the Ethereum network knows that you want to do this transactions. And there are a lot of Ethereum providers. They are good, but not compulsory. You can have them, not have them, XYZ. Okay? And then those communicate with the Ethereum blockchain and you get back the result. So there is a complete layer of transparency. You can look at this any day. You can look at this any day. You can look at this any day. All of this code is with you. There is no code which is on server behind closed walls, right? So yeah, that's what smart contracts are. Ethereum virtual machine, as I told you, is like a virtual distributed machine which stores like this unified state, and everyone agrees to that state, and gas fees is what you pay to do any transaction on the network. Okay. So yeah, I was gonna do the meme of Nemo removing his glasses and him being the oracle. So yeah, there is a problem here. Does anyone know what the problem of smart contracts is? There's a major problem in smart contracts. Like someone actually highlighted it with the hospital example. Does anyone know? There's one thing missing in smart contracts. It's so good. Insurance money gets distributed equally. Everything is fair. Any idea, guys?
Anyone can duplicate it.
No, I mean, that is okay, but then marketing can get over that. That's not a problem. Someone talked about fraud and how hospitals could do fake records and stuff like that.
Validating stuff, right?
Validating stuff that is not on the chain. So we know mathematically, because of my bad examples of human feces, that the chain will always be the longest chain, and you can believe any data on the chain. So anything on the blockchain is validated and the whole world agrees to it. But what do you do for things like weather data? Okay? Because a lot of apps use weather data. What do you do about stock prices? Okay? What do you do about, for example, in insurance case, blood samples? All of these are external to chain. They're also called off-chain. Okay? So most contracts, if they want to materialize in the real world, would require off-chain interactions. So what some of the most, and these off-chain interactions are supported by some things called oracles, because they know everything and what they know is right. That's why I put the matrix meme there. I don't know if you guys got that, but anyway, they know everything. And how do they know everything? Again, using the principles of blockchain and distributed information. So instead of taking weather reports from one center, they take weather reports from a multitude of centers, and sometimes even encourage people to host their own weather modules and pay them transaction in blocks or coins, so that you contribute to the continued sustenance of the longest chain. And so these are usually parallel chains running for weather, or even distributed systems that actually collect data for weather and validate each other, and then is used as input to the blockchain's parameters from outside world. That's what oracles are. So you will come to this term once you start developing in Web3, and that's what these things are. Cool. And the last thing is interplanetary file system. That's about it. And after that, we're done. So there's another problem with blockchain. Can someone tell me what the problem? Another problem with blockchain is. One is this: there is no source of truth for outside data. There's something else. Any idea? Has something to do with gas fees. Okay, so second problem with blockchain is it's very expensive to store everything on the blockchain. Just think about this. Think about a world where your blockchain stores all of your stupid Instagram posts, okay? All of the stupid Snapchat, videos that you send, and everything like that. It would take an enormous amount of resources to do that. And the gas fees would be so crazy that you can just literally buy a new house. So we don't do that. So what usually happens is there is this thing called the interplanetary file system. Now, why is it called the interplanetary file system? And that's why I have this thing. We get YouTube on Mars. So the creator of interplanetary file system came up with this name because they wanted Mars to have internet. I hope Elon Musk stays there, but whatever. Okay. So the problem with Mars is when it's closest, about 6 months away, I think, and the furthest it's about 4 years away. Okay. When it's 6 months away is when we usually send the rovers. Okay. The time that requires for data to go back usually ranges from a few minutes to multiple minutes, a few seconds. I think the closest, it only takes 10 seconds or something, processing time of a few seconds, and return back 10 seconds. And otherwise, when it's very further away, it takes about 20 minutes. So there's a 20 minutes delay. So what they thought of is, why not store all of the data of the internet on just individual distributed nodes, just like, the blockchain is. That's what interplanetary file systems. Okay. So what it does is, all of your computers, you can actually participate for this. They have their own coin. It's called Filecoin. Okay. So you can, if you have a SSD of 1 TB, you can actually connect it to the internet and say, I will provide it as a source for interplanetary file system, and data is stored on that and retrieved. So instead of using AWS, now using multiple computers and copies and cached copies of that. There is an example, real life example of how this works already. Any of you guys have used torrent? uTorrent? Torrent? Yes?
Yes.
Anyone knows why it's hard to ban these things? Like, think about this. Now, they are making so much loss for the government, companies, etc. Why is it so hard to ban them? Any idea? Do you guys even know how uTorrent works? Or any torrent site works?
Because of the seeders,
What does seeders do?
they store a copy of the file, and like any new person would want to download it, they could just connect to that server and.
Exactly. So it's a distributed file system, just like interplanetary file system, right? You keep a copy of the file. So, for example, a YouTube that's built, I think there's a YouTube built on IPFS. You might explore that if you have some few minutes. What would happen is, when you watch a YouTube video, it would store some of the video that you've already seen, so that when someone else watches it, they can fetch from you instead of server from YouTube. So yeah, that's
So
how
it encourages piracy, and government wants to stop it, but seeders won't let it do.
Yeah, like for example, what they will come and arrest Rahul Mohan for storing 1/4 of the part of some stupid movie in 450 pixel? No, they can't. There's not even a legal way to do it. So that's why torrent is impossible to ban. I can just make a torrent link right now of the video we are streaming right now and share it with you guys, and you will still get it, regardless of what government does to do. So yeah, it's a distributed system, and that's why people are so crazy about Web3, because Web is all about freedom. And you guys might have seen recently there are a lot of rules put on there and stuff like that. So, good. I think we all can come to query session now. Sorry if that went long. Okay, you guys can ask, and I think OP and Lipsa will join and answer any questions you guys have.
I have one question. So during the start of the session, Lipsa said something about ODS So is this audience somewhat related to Spotify that we use?
Sorry, I don't know. Lipsa, can you maybe?
Yeah. Audience is a DApp, and yeah, as I mentioned, it's not an intermediary. It's driven by the users. Yeah, similar to Spotify.
Oh, okay.
It's not a middleman.
So
I think it's right.
Kind
Lipsa?
of music platform, better to say.
Yeah.
Yeah,
okay.
please go ahead.
So the question is like, if means Rahul, as you mentioned that we are paying high gas fees when we are putting some large video or some large files. So how that is going to be a user point of view, is user experience, how it will happen going further, means seeing somewhat in 5-10 years.
So for example, the app, right? I've never used that app, the distributed music platform. So how it works is, and I'm how presuming because I know some things about how the Web3 architecture works is, if you want to actually get a video from, for example, you have music, right? You have music albums on this platform, right? It may be free or not free, God knows, but then most probably it has some albums, right? So these albums that you have on the platform, okay, how it works is, so assume you want to buy an album. So you go to a normal store, okay? If you remember the old days where you used to actually buy albums and things, okay? You used to go to a normal store and actually pay for an album and you would get all of the albums. In this case, what would happen is, if you want to actually own the album, you just go to the DApp and in the smart contract, you deposit some amount of money with the gas fees, right? And then you would own the whole, this music library like, you would. And if it was a streaming platform, it would be completely based on IPFS. And all of the music would be stored on IPFS. It would not be stored on the blockchain. That would be stupid. The only thing that will be stored on the blockchain is the ownership of the library. Like, what would be stored on the blockchain is the person's hash with the hash of the whole music library saying that I own this, like Rahul Mohan owns this. That's the only thing that would actually be stored on the blockchain. Okay. Oh, God knows what I'm writing on. But yeah, so that's what would be stored. When you talk about gas fees and the problem with gas fees, it's a major issue. And I'm good that you highlighted it. I want to show you something to make you happy about the gas fees, because gas fees is not as high as it used to be. Like in the sense ki, let me actually bring up that platform. One second. I have a lot of things here. I'm so sorry. Yeah. So if you look at this currency, right? It's a cryptocurrency that supports smart contract. Solana became very popular. Okay. It's based on a completely different trust system. Okay. It's something called proof of stake with time. Okay. I forgot what the exact name of the paper was that actually introduced this. So if you look at this, the transaction fee is $0.00025, which is 0.0014 rupees. Do you really mind transactioning this much instead of paying 3% to credit card companies? I think this is okay, right? Yeah.
So what he was trying to ask, what I understood is that if, we are trying to upload a content of, let's say, 1 MB versus trying to upload a content of 100 MB. So is that independent? Is gas fee independent of the volume of the content we're uploading? It just depends on the hash.
Yeah, basically. And so there might be some transaction fees to put a lot of data on the IPFS. Okay, because IPFS has now a coin, but again, that is completely it's a system where it is not as exorbitant as you think, right? You don't have to put a gas fees there. There's a different gas fee there, and that is also very cheap compared to other hosting platforms. And the best part is, okay, so for example, I now own the album. Okay, the album was generated because of a smart contract. If I want to give it to my friend, I'll have to go and talk to the original smart contract to change the ownership from me to someone else. Okay, and in that smart contract, the author of the music can write a royalty fees when he gets 20% of that transaction. So that the content creators who are actually the ones making things get money. It's like saying if we had a decentralized vegetable shop, farmers would earn the money. farmers would get the royalty, not the middleman would be. So that's a good example of how, if it works well, it would. There are a lot of issues. There are a lot of scaling issues. There are a lot of issues that I've not discussed in detail.
Rahul, I had a question about NFTs. So as you said, this meme, which is now an NFT in your account, about the cat one, I believe. So just an example. Yeah, this is an example. So like on the internet, we have a lot of images, like everybody is just using it at their disposal. So how does NFT exactly solve this problem, and what is the benefit to the owner of this NFT?
Yeah. So for example, assume that the original owner who created it, and he's the one who made the NFT, right? The original who created that cat GIF, right? So original guy who created the cat GIF, what he did is he took a copy of it, okay, and he had a recognizable hash, which is very unique to the internet. Okay. He tweeted out saying, "Guys, you remember I created this thing? Now I have an NFT for it." Okay. And because you know this guy, you are like, okay, cool, NFT. And the new image that he has created has the hash attached to it with the name of this person. And because you don't have private keys for this, you can never create a combination of these two keys on the blockchain ever. So the creator can. There is a question of whether he was the actual creator, and I understand that. That is still a problem. We need to have more better systems for that. But you understand that this key is unique, i.e. the NFT. If I upload an NFT of the same cat, I wouldn't make that much money because I'm Rahul Mohan and I'm nobody.
Okay, cool.
Hello.
It's just an example of the Mona Lisa. If you can make a, obviously you'll see high resolution prints of the Mona Lisa. You can't print it and, oh, I have the Mona Lisa copy. Okay, whatever. Yeah, go on. I think GPU wanted to ask a question.
Yeah. So what I understood was like, for example, in OpenSea, right? The backend is in the blockchain. So we have it's smart contract that we could go and see and read and everything. So if I just copy the entire code, make some changes so that I get the commission, then I deploy it in the blockchain and I write my own front end. Suddenly I'm a competitor to OpenSea, and the only difference is marketing.
Yeah. Isn't that the best? Isn't that the
cool.
Because you literally can improve a service you don't like, and if you have to fix, go and like get lost.
That's crazy. That's crazy.
That's the beauty of the blockchain. See, I am giving you rose-tinted glasses opinion about it. There are issues, and we don't have time to discuss all that issues. I would like go crazy on the 3-hour rant on why there are issues, but then yeah, that's the freedom you get.
Okay, thanks.
Okay. OP, if someone has questions to OP is very good in architecture. I think he can answer a lot of scaling questions. He's like a brilliant lead, so you can go ahead and ask him.
I believe the politician helped them a lot. We are going to.
Politician had a busy day, OP. That's that track will be hard. Okay, guys. So can everyone share the link of the feedback?
I can share the link of the feedback. Give me a moment. Where I kept kind of. Let me validate it first before I jump. One sec, guys. Yes, I got it. I got it. Copy link. And so, yeah, here we go. And we have a timeline of 1 day, right, Rahul?
Yeah, we can't mint tomorrow. Even if the world wants otherwise, you will not get the same NFT as today. So That's how the blockchain works. So today I'll send over the emails to everyone. Just do what I showed you. Open the app, put your token in, done. NFT minted.
And guys, those who missed this session, we are going to publish the YouTube link, and we are also going to publish the share slides link. And this time no GitHub, because code is not so much we want to share with. It's just kind of a beginning. So yeah, slides are and YouTube link.
Can you
So,
share your email, Twitter handles?
Yeah, sure.
yeah. I think for me, I'm not quite. I'm mostly using emails, so posted my email details there. But Rahul, you can proceed with whatever you want.
So I'm the real Rahul Mohan at Twitter. You need to reach out to me. There is no fake Rahul Mohan.
Lipsa.
Yeah, same here. Gmail. I'm
yeah.
not a Twitter buff, Twitter Latino.
Yeah. So Lipsa, you posted on direct to me instead of.
Sad. Okay.
Okay.
Cool.
So we'll try to help out whenever it's possible. You can also paste your questions on the meetup page. So yeah, we will be there to answer. And YouTube links and slides here will take a week to roll out.
Feel free to reach out to me on Twitter or OP on email. I think we have
Lipsa too.
And if you want to reach out to me, I'll just direct you to Rahul and OP. Because I'm literally a beginner and I jumped in just out of excitement. Somebody is at my door again.
So, and again, guys, if you are looking for a change, you're looking for an organization to grow, I think Analytica is a good one. So feel free to reach out to.
Yeah, we have more than 100 openings as of today. And not only in a particular area, you can get rich areas like cutting edge on maybe AI, machine learning, big data, investment banking, big whatever.
So is this company based out of Pune?
Yes, and we are going to open in Bangalore as well, and we are also thinking for few other locations too, but those locations are not disclosed to us as at a moment. But yes, we are going to come up with an office in Bangalore post pandemic. Currently we are on work from home stuff.
Okay.
Yeah.
So no chance for people from Mumbai.
Yeah, no, it's nothing like that. You have an opportunity to work from home, right?
Right.
So no matters you are in Mumbai.
Model has changed.
But I think Mumbai can be a potential location, but I'm not aware of the management decision, so it's hard to commit anything.
We are technical folks, right?
Yeah.
It is included because HR says, guys, you are doing this crap. Include on it.
So this webinar was conducted by the company, or you folks just, you're coordinated for a weekend or something?
Okay, so what we used to do is initially when we are on offline mode, we used to also serve the snacks and few other stuff, souvenirs to the attendees. So that time it was funded by the organization, but due to the momentum we receive over the time, currently this community has more than 2,200 what to say followers. So we keep on the momentum and still going on with the flow. Even we are not getting that push from the organization. So if you want, you can also discuss some thoughts in the coming meetup. You can connect. So
completely.
We are open.
completely volunteer.
No, I should be saying like this was my first ever meetup webinar, and it was quite a good for a start.
Yeah, thank you. And thank you. You joined meetup groups and talent.
Thanks to all of you.
No more JS as well. And you have really good, what to say, you have already putting a lot of good things over the discussion. So yeah, it was nice to have you here.
Thank you so much.
Mhm.
I mean, a little bit of joke. The no more JS, if wrong, I mean, heard wrongly, it can sound like no more JS, no more JS.
But it's no.
It's actually no more JS, a little bit ambiguous.
No one on English
No
stuff.
more JS, or okay.
It's the English, it's the no more jail, not no more jails.
Anyways, so shall we wrap up, or we have a few more opinions or to discuss?
So when is your
Guys,
next meetup?
next meetup will be in next month. So we try to conduct every month. It's basically on Saturdays, and yeah. And we also request in the feedback form, if you are looking for a specific topics which you guys want us to cover, we'll happy to explore those. And yeah, it could be anything in any direction we will try to cover. Your feedback matters to us.
Sure. Thanks. Before leaving, I would just like to thank Lipsa, OP, and Rahul for taking
Thank
their
you.
time. Generally, we don't find detailed information over the web, as in, proper in a proper structured way. So thanks for sharing your knowledge with us. It's really helpful. Thank you.
Thank you.
Yeah. Thanks, guys. And Vinay this side. So thanks, Rahul, Lipsa, and OP. It was a wonderful session, I say. So I've been watching and reading about Web3 a lot, and then this is my first meetup on Web3 and things like this. But it actually gave me a quite good insight about, and also Rahul shared real-time examples and how to maintain an FT, and those things were really great. I'd love to explore more. Yeah.
Yeah, that's the one reason I want to a little bit faster than everyone else in the session, so that Rahul get a more chance, because real-time example will really help people
Yes.
to understand the stuff.
Yeah,
and
thank you
my
very much.
politician was really helpful to me.
Really, that gave a bit of background, and then Rahul took up explaining the real-time example, which actually made things very clear. Yeah.
Thank you.
Thank you. Thanks, guys.
Shall we call it a day?
Let's close the meeting. Okay.
Thank you everyone for joining us. We'll be waiting for your feedbacks, and you should expect the NFTs.
Yeah.
Okay. Thank you.
Already done. Thank you so much.
Okay,
Thanks
that's wonderful.
Thank you. Thanks for
Okay.
your time.
So
Thanks
close.
everyone for joining.
Yeah.
Okay.
Ending
Have a
this.
good day.
Thanks.
Thank you. Bye-bye.